Geometry, Unit 4, Lesson 8. I can use the converse of the Pythagorean theorem to identify right, obtuse, and acute triangles. So, the Pythagorean theorem, if we have a right triangle, then a squared plus b squared equals c squared. Let's do the converse. If a squared plus b squared equals c squared, then we have a right triangle. So I just reversed the hypothesis and conclusion there. So let's take a look at this triangle right here. You probably already recognize it as a right triangle because it's really a 3, 4, 5 with a scale factor 2. But I believe it is a right triangle. And we're going to prove it is by making sure a squared plus b squared does equal c squared. Notice I shifted it around. And the reason I did that today is because I really have to focus on the longest side. Trust me, put a box around it and start with c squared equals a squared plus b squared. Let's go ahead and substitute in just looking here. I'm going to go ahead and do my annotation. That's my c. It's going to go right here. So this will be 10 squared. And then I have 6 squared plus 8 squared for the legs. We have 100 equals 36 plus 64, and 100 equals 100. When this happens, we have a right triangle. That's all the proof you need. Again, notice the longest side went in for the C. So I'm going to come down here to my conclusion. If c squared equals a squared plus b squared, then a, b, and c form a right triangle. So let's go up and take a look at the next situation. I want to sketch a 6, 8, not 10 over here, but 6, 8, 11. So my longest side is actually a little bit bigger. So I think it's going to be a little more obtuse. 6, 8, and 11. And you can see I made this longest side a little bit longer than what it was before, and I needed more space. That's why it opened up. So keep doing the annotations. That right here would be your C. And I think it's going to be obtuse. I'm not sure, but that's my conjecture, my educated guess. Because I had to make that longest side even longer. And let's go ahead and substitute in. Our C is 11. And then we have 6 and 8 for the legs. And this 121, that was our longest side. Notice it's bigger. So if the longest side squared is bigger than the squares of the legs summed up, then you're going to end up having an obtuse triangle. Because as this longest side got bigger, this side and this side had to open up further to let it in. So that's going to be obtuse. The tricky thing though is when you get down here, sometimes you forget which one was your longest side. I always like to put a box around my longest side, and sometimes I carry it all the way down just so I don't forget that was my longest. And if the longest side turns out to be bigger now in the end, it's obtuse. I'll even go back here and do the exact same thing. You're always keeping an eye on your longest side. So if I come down here, if your c squared, your longest side, turns out to be greater than the sum of the squared legs, then you have an obtuse triangle. Lastly, we're going to have a 6, 8, 9. So we already had a 6, 8, 10. I think this one's going to be more obtuse because we took what was a 10, and that used to be a right triangle, and we made it a little bit smaller. So I'm going to go ahead, same annotation. That's my C. Come down here, substitute in. I think this will be acute. Let's go ahead and substitute 9 for your longest side. And you can see, again, I like to box my longest. The longest side in this case turned out to be less than the squared legs summed up. And when it's less, it's smaller than, these sides here will close up a little bit to as this longest side gets shorter. Okay? So therefore, you have an acute triangle. So if I come down here, and your longest side squared is less than the squared legs summed up, you have an acute triangle. So right now, you can hit pause and try these two. Go ahead and classify them as obtuse, acute, or right. And you want to see, using the Pythagorean theorem and these little conclusions we just came up with. The other thing is, though, because I like to try and trick you, you need to first see if it even is a triangle. Is it even a triangle? And remember, the two small sides, their sum must be greater than the third. So you can hit pause and try it now. Okay, here I go. Turns out, here are my two smallest sides. And if I go ahead and do 5 plus 4, is that greater than 9? 9's not greater than 9. Therefore, this is not a triangle. So you don't classify it. You don't do anything else because it's not even a triangle. We'll move on to the next one. Okay, I'm going to double check. My smallest sides here are 5 and 8. I come over here. 5 plus 8, is that greater than 9? 13 is greater than 9. Therefore, it's a triangle. Check. So now that we've figured that out, let's go ahead and try and classify it. Remember, your longest side now, that's your C. And I like to start with C squared equals A squared plus B squared. Here's your longest. Okay, keep an eye on this one. 9 squared, 5 squared plus 8 squared, that's 25, 64, 81, and finally 81. 25 and 64 is going to be 80, that's 89. So keep an eye on your longest. Did it come out to be bigger, equal, or less? And it turned out to be less. So the longest side all of a sudden became less. It got smaller, making this an acute triangle. Okay, last one. Again, feel free to hit pause and try it out. All right, here I go. Looking for my two smallest. Need to make sure this is a triangle first. All right, it is a triangle. And now I'm going to go off to the side. C squared equals A squared plus B squared. Okay, this is my longest side. That's my C. I'm going to keep an eye on this. Let me go ahead and substitute 12. And I get 144 on the left. Here I get 120. It looks like that's 130. This was my longest side the whole way down. If you box it, you won't forget it. Sometimes you think it's this one. And that longest side got even bigger. Remember, if they were equal, it's a right triangle. But the longest side got bigger, which means the only way it would fit is if it opened up and made it an obtuse triangle. So in summary, first check to make sure that it is a triangle. If it isn't, stop. If it is, then do the converse of the Pythagorean theorem. If it comes out equal, it's a right triangle. If the longest side is bigger, it's obtuse. If the longest side is less than, it's acute. Good luck.